If you have followed our lessons so far, you will notice that we always classify light as an electromagnetic wave that has all the properties of a wave: reflection, refraction, interference, and so on. Also, we have always referred to small particles like electrons as particles that have mass, charge, and can collide with other particles. Now we are about to enter an interesting field in physics called quantum physics, where all we have discussed on light and small particles like electrons still holds, but they also share something very unique. As scientists continued to study particles like electrons and electromagnetic waves like light, certain characteristics were observed that seemed to suggest that light acted as a particle and electrons also acted as a wave. Even though this may sound strange to you, it is true, and it is what is called the wave-particle duality of matter. It was also difficult for scientists to accept this fact until Albert Einstein used the photoelectric effect to explain this. In the photoelectric effect, electrons are ejected from thin metal sheets when light of a certain wavelength is focused on it. Einstein explained that light acted in packets of energy called photons. This meant that light acted like it was made up of tiny particles called photons. He stated that light of different colors consists of photons of different wavelengths. This means the photons of green light and that of red or blue light will have different wavelengths and frequencies. He stated that electrons only absorb photons of a certain energy that was related to the frequency of the light it was produced from. This energy, E, is equal to hf, where f is the frequency of light and h is called the Planck's constant. This was introduced in our lesson on the photoelectric effect. So when light with a high amount of energy hits a metal sheet, electrons will be ejected with energies that have frequencies equal to the frequency of the light that is projected on the metal sheet. But if the energy of the light is very low, it might not be able to eject the electron. This is similar to a cue ball traveling at a certain speed on a pool table to a ball placed in a circle. If the speed and energy of the ball is high enough, it will hit the other ball with a force that will make it leave this circle. But if the speed is not high enough, it will not leave the circle but might move a bit. Also, when you pass light through two tiny openings called a slit with some distance between them and place a screen behind the slits, you will notice a bright and dark pattern on the screen. These patterns are created as a result of light interfering after being diffracted. So the area with bright patterns are the constructive interference and the dark patterns are destructive interference. These two phenomena are properties of waves. This was first observed by Thomas Young and is called Young's double slit experiment. But when you replace this light with electrons, a similar pattern is observed. This implies that electrons also behave like waves. So as you can see, the photoelectric effect and Young's experiment shows that light and electrons both behave like particles or waves depending on the experiment or effect. We shall continue our exploration on this in our subsequent lessons. See you there.